Let's discuss angular displacement, angular velocity, and angular acceleration. Why do we need these things in circular motion? And all these things we'll discuss in this part. Suppose our object is at this position, the initial position, and after some time it is found at this position, final position. Initial, final, radius is r. Now we already know two things. This path length is called what? Distance. This shortest distance between initial and final is called what? Displacement. And now we define this theta, which is what? Angular displacement. चीजों को प्रेजेंट करने के अलग अलग तरीके, कहानी एक ही है. Object is moving from this position to this position. Somebody says that he is into distance part between initial and final. He will define this path length. Between same initial and final point, if somebody looks at this blue line, shortest distance between initial and final, then he will go for displacement vector. A third person, he is into this angular disturbance and says that this theta is angular displacement. Now, which means we are artificially defining all these things. हमारा काम डिस्टेंस से भी चल सकता था, हमारा काम डिस्प्लेसमेंट से भी चल सकता था, लेकिन हमने यहां सर्कुलर मोशन में क्या चीज नोटिस की, that if your distance as you move does not change from a fixed point, which is called what? Center, then you can also define this angular displacement as theta. इसका क्या एडवांटेज होगा? जब वो आप समझोगे तो आपको इस थीटा का इंपॉर्टेंस क्लियर होगा. इसलिए देखते जाना, थोड़ी देर में पूरी कहानी क्लियर हो जाएगी. नाउ हमने थीटा को डिफाइन कर दिया है एज व्हाट? एंगुलर डिस्प्लेसमेंट. Now, this angular displacement theta is not always a vector because it doesn't follow triangle law of vector addition. But if this theta is very small, if theta is very small, then this theta behaves as a vector. I said behaves as a vector. ये terms and all with time आपको समझ में आएंगे, परेशान होने की जरूरत नहीं, बहुत खतरनाक नहीं है. सर्कुलर मोशन को इजी बनाने के लिए हम लोग इस थीटा की तरफ चल कर आए हैं. जैसे ये थीटा है, वैसे हमारे पास क्या हुआ करता था काइनेमेटिक्स में? Displacement. And then we used to define rate of change of displacement as what? Velocity. Similarly, we define omega. What is omega? Omega is called angular velocity. Now, what is angular velocity? rate of change of angular displacement. How do you define rate of change? With the help of this d theta divided by dt. Now, this omega is always a vector. Why? Because we have introduced a concept that if angular displacement is small, then it is a vector. Now, what is omega? D theta. What is d theta? Something which is very, very small, and therefore this d theta is a vector. If it's a vector, that means omega is also a vector. क्या हो रहा है यहां पर? If somebody moves from this position to this position, then you can see that theta is 90. This angular displacement of 90 degrees will not be considered a vector. But if you move from this position to this position, very small deviation means 0.000000001 degree. इस तरह की छोटी चीज उसको आप क्या बोलेंगे? वेक्टर्स. जैसे ही आपने बोला थीटा इज वेरी स्मॉल एंड इट इज अ वेक्टर, then this omega, which is d theta upon dt, d theta being small becomes a vector, and therefore your omega is also what? A vector. Then comes alpha. What is alpha? This is what? Angular displacement. This is what? Angular velocity. This is what? Angular acceleration. Your alpha is angular acceleration. What was simple acceleration? Rate of change of velocity. What is angular acceleration? Rate of change of angular velocity, which is d omega by dt. d omega by dt. Since omega is a vector, this d omega is also a vector, and therefore alpha, this is also a vector quantity. हमारे पास क्या क्या कहानी डेवलप हो गई, एक बार फिर से सुन लेना. Theta is called angular displacement, which is not always a vector. It is a vector if it is very, very small. That's how we have defined it. That's how we have defined it. अगर आप थीटा डिफाइन नहीं करते, तब भी इस सर्कुलर मोशन के अंदर जितने भी क्वेश्चंस बनते उनको आप कैलकुलेट कर सकते थे, the way we did in projectile motion. What is projectile motion? Projectile motion is also a two-dimensional motion. And how do you handle that projectile motion? By resolving velocities, displacement along x-axis and along y-axis. You could have done the same thing with this circular motion also, but we don't go for that. Why? Because calculation part will increase, difficulty level will also increase if instead of resolving all these vectors along x and y, we go for concept of angular displacement, then we can handle the circular motion in a very easy and convenient way. कैसे देखेंगे उस चीज को, चीजें थोड़ा टाइम के साथ क्लियर होती जाएंगी. अभी के लिए angular displacement, if it's large, it's not a vector. Small, it's a vector. Omega, rate of change of angular displacement, is what? Angular velocity. It is d theta upon dt, d theta vector. साथ में आपको इस ओमेगा का यूनिट भी दिख रहा है, d theta divided by dt, radian per second. What is angular displacement? Its unit is what? Radians. What is alpha? d omega by dt. What is omega? Radians per second, and therefore this thing is coming radians per second square. Radians per second square. That's what? Unit of alpha. नाउ अभी थोड़ी देर में इस रेडियन फॉर्मेट का डायमेंशनल वर्जन भी देखेंगे. उसके लिए जरा यहां चलते हैं. This distance part between initial and final, from this to this whole thing is arc length. Arc length. And we have defined arc length like this. Arc length, which in this case is nothing but distance, is defined in this form, r theta. In fact, a much better version is this. If somebody says that arc length is L, arc length or distance is L, this L is nothing but distance. But not any distance. That distance in which your distance from center as you move remains same. I'm using two distances, don't get confused. As you move from this point to this point, your distance from center is always what? Same, r. Then this distance which you move is what? Arc length is what? L. Theta is defined as L upon R. 12 तक पहुंचोगे तो आपको क्लियर होगा. This theta is called plane angle. वहां पर आप solid angle का concept भी देखोगे. Solid angle is something which a cone forms at its vertex. That we'll see in 12. Right now, this theta is what? Plane angle. How do you define plane angle? Arc length divided by r. What is L? Meters. What is r? Meters. And therefore, this theta is a dimensionless number. Dimensionless number. But this dimensionless number has a unit which is what? Radians. अब किसी ने आपसे पूछा what is the dimensional formula of theta? आपको पता है? What is dimensional formula? m0, l0, t0. It has no dimensions. There is no mass, there is no length, there is no time. Meter upon meter cancelled. कुछ बचा नहीं इसके अंदर. And then everybody can easily write the dimensional formula of omega. What is dimensional formula of omega now? There is no dimensional formula with radians, and therefore dimensional formula will be simply m0 l0 t to the power minus 1. And the same way you can go for dimensional formula of alpha, which is m0 l0 t to the power minus 2. Why t to the power minus 2? Because of what? Second square radians. It has no dimensional part. Now, in this, what we have seen so far, we have found angular distance or angular displacement. Angular displacement, its relation with what? Its relation with what? Arc length, and that is L equals to R theta. Note down this much. Now let's relate angular velocity with velocity, that is v and omega together. अभी तक हमने क्या चीज रिलेट कर ली थी? हमने L, which was distance, इसको रिलेट कर दिया था किसके साथ? Angular displacement के साथ. L, which is the arc length, इसको हमने रिलेट कर दिया था किसके साथ? Angular displacement के साथ. Now we need a relationship between v, velocity, and omega, which is angular velocity. Look at this figure. This black path is what? Distance. This blue part is what? Displacement. When we define v, we do not say rate of change of distance. We say what? Rate of change of displacement. And how do you write that? V is ds divided by dt. What is S? Displacement. What is ds? Small displacement. But what is L? L is arc length. This is the arc length. And what is arc length? Distance. And therefore we should convert this distance into displacement. क्या करेंगे? कुछ खास नहीं. Look at this ds. ds का मतलब क्या है? अगर आप इस सर्कुलर पाथ में you start moving from this position to this position such that your angular displacement is d theta. What is d theta? Something which is very small. Then this path length will be what? dl. If this is d theta, then this path length is what? dl. What is dl? Distance. But this dl is also ds. What is ds? Displacement. What is d theta? Angular displacement. What is dl? Distance. What is ds? Displacement. क्या करना पड़ा? d theta. फायदा क्या हुआ? If you consider a very large portion of the circle, something like this, then arc length, which is distance, is different from displacement. But if somebody goes for a very small arc length, if somebody goes for this small arc length from this point to this point, then it almost loses its curvature, and therefore distance and displacement, they both become what? Same. For large curvature, distance ज़्यादा होगी किससे? Magnitude of displacement से. But for small curvature, for small movement, जो distance है और जो displacement है वो दोनों क्या हो जाएंगे? Same. That means this dl is nothing but ds. But what is dl? From this we can say that dl arc length is r multiplied by angle formed by the arc at the center. Remember it like this. What is arc length? Arc length is radius multiplied by angle formed by the arc at the center. What is that? d theta. This dl is what? Arc length. But this dl is also what? ds. Now we are interested in what? V. What is V? ds by dt. What is ds? ds is what? r d theta. R d theta all divided by what? dt. Now what is d theta by dt? We have defined d theta by dt as what? Omega, and therefore V becomes what? R omega. V becomes what? R omega. This is relationship between tangential velocity. What is V? What is V? अगर आप यहाँ पर हैं, then V is like this. What is the direction of V? Along the tangent. And therefore this V is tangential velocity. What is omega? This omega is angular velocity. V is tangential velocity, omega is what? Angular velocity, and this is the relation between these two things. Now, एक बार आपको V और ओमेगा का रिलेशन मिल गया, तो फिर आप एक्सेलरेशन एंड एंगुलर एक्सेलरेशन का रिलेशन भी निकाल सकते हैं. किस तरह से निकालेंगे? यहां देखना. V is coming R omega. Let's differentiate this whole thing. dV upon dt is what? R multiplied by d omega upon dt. What is dV upon dt? What is dV upon dt? Acceleration. A. What is d omega upon dt? Rate of change of angular velocity, which is alpha. This is the relationship between acceleration and angular acceleration. Now, look carefully. What is V? Tangential velocity. And therefore, this A, which you see, is tangential acceleration. ये tangential acceleration, centripetal, angular, जब तक आप कुछ एग्जाम्पल्स नहीं करेंगे थोड़े से कंफ्यूजिंग रहेंगे. एक बार आप एग्जाम्पल्स एंड ऑल में आ जाओगे तो फिर आपको इनके अंदर के जो डिफरेंसेस हैं वो इजीली दिखने लगेंगे. व्हाट इज दिस अल्फा? दिस अल्फा is angular acceleration. And I say कि differences दिखने लगेंगे tangential and all इस तरह के. किस तरह की बातें हैं? What is A? कुछ लोग A को A total समझते हैं, कुछ लोग A को centripetal समझते हैं, लेकिन ये है क्या? This A is what? Tangential acceleration. We know that acceleration has a centripetal component, a tangential component, and then total. Total के दोनों component हुआ करते हैं, centripetal and tangential. तो ये जो A आपने calculate किया हुआ है R alpha, what type of A this is? Tangential acceleration. Centripetal बाद में देखेंगे अपन लोग. Relationship between tangential velocity and angular velocity. Relationship between tangential acceleration and angular acceleration. Now, यहां पर अब इस चीज को डिस्कस कर लें कि हमने क्यों ये थीटा, वेलोसिटी, अल्फा इन कॉन्सेप्ट्स को डेवलप किया. तो फिर हमारे लिए सर्कुलर मोशन के पार्ट को आगे ले जाना इजी रहेगा. Suppose somebody has defined a uniform circular motion. Somebody has defined a uniform circular motion like this, in which velocity magnitude is same throughout. Uniform circular motion. Magnitude of velocity is what? Same. अगर आप वेलोसिटी वाइज बात करते इसको डिफाइन करने की, then velocity is not uniform. Only the magnitude of velocity is uniform. Direction is continuously changing. And therefore, although you are saying uniform circular motion, but still something is there which is changing. What is that? Direction. Now, लोगों ने सोचा कि एक काम ऐसा किया जाए कि इसके अंदर कुछ भी चेंज ना हो, and then they went for this concept of theta and omega. What is omega? Rate of change of angular displacement. Look here, you can also feel it. If you are at this place, you are at this place, or you are at this place, if your velocity is same, your omega is also same, which is also clear from this. If your v is same, omega is also same. Same distance, same distance, same distance. यहां पर आप जितना आगे चलेंगे dd टाइम में, जितना आगे चलेंगे dd टाइम में, जितना आगे चलेंगे dd टाइम में, उतना ही आपका क्या होगा d theta at every place. Now, but the problem with v is direction is changing. तो अब लोगों ने क्या डिफाइन करना शुरू किया? डायरेक्शन ऑफ एंगुलर वेलोसिटी. हाउ कैन यू इजीली डिफाइन दैट? लुक एट दिस सर्कुलर मोशन. व्हाट टाइप ऑफ सर्कुलर मोशन डू यू सी? क्लॉकवाइज और एंटी क्लॉकवाइज? तो आपने बोला दिस इज एंटी क्लॉकवाइज सर्कुलर मोशन. सर्कुलर मोशन can be easily classified into two types of: one clock, other one anti-clock. This is clockwise, this is anti-clockwise. Now, if I ask you what is the direction of velocity at this point, then you will say north. What is the direction of velocity at this point? Somebody will say west, south, east. यहां पर नॉर्थ ईस्ट, कुछ और अलग अलग पॉइंट्स पर अगर आपको वेलोसिटी डिफाइन करनी होती, देन देयर आर इनफाइनाइट नंबर ऑफ डायरेक्शंस. अलग अलग जगह पर कितनी कितनी डायरेक्शंस बनेंगी अलग अलग, and therefore there are infinite number of ways to define this velocity. Although magnitude is same, but still there are infinite number of velocities possible. North, थोड़ा सा वेस्ट की तरफ, कंप्लीट वेस्ट, साउथ, ईस्ट, और इसके बीच में बहुत सारे. बट नाउ लुक एट दिस. अगर आपने इस पार्ट को देखा जहां पर v आपका सेम है, तो आपने तुरंत बोला कि भाई ओमेगा एंगुलर वेलोसिटी क्या बनी हुई है? कांस्टेंट. एंड व्हाट टाइप ऑफ रोटेशन डू यू सी? व्हाट टाइप ऑफ रोटेशन डू यू सी एट दिस प्लेस? एंटी क्लॉक. एट दिस प्लेस anti-clock, at this place anti-clock, at this place anti-clock, and therefore we can define this whole circular motion, which is uniform circular motion, with the help of a single unique quantity. And what is that? Omega. यहां पर velocity infinite ways में define होगी, ओमेगा केवल एक तरह से define होगा. What is that? एंटी क्लॉक और क्लॉक. होपफुली आपको ये चीज समझ में आ रही है क्यों हम v से ओमेगा की तरफ मूव करना चाहते हैं. अब इस ओमेगा को हमने थोड़ी देर पहले देखा था. वी हैव डिफाइंड दिस ओमेगा एज व्हाट? वेक्टर. एट द सेम टाइम वी हैव डिफाइंड d थीटा एज अ वेक्टर. ये जो डायरेक्शनल पार्ट है, इस डायरेक्शनल पार्ट को प्रॉपर तरीके से किस तरह से हम डेवलप करेंगे? लुक एट दिस. This clock and this anti-clock. In vectors, you can define clockwise and anti-clockwise in this form. Clockwise, look at this right hand. Thumb is pointing inwards, and therefore, if I ask you what is the direction of omega in this figure, you will say direction of omega is inwards. Inwards with the help of what? Right hand. Look at the curve. This curve and thumb inside. Inwards, you know, are shown, inward vector, they are shown with the help of what? Cross. जो वेक्टर आपकी तरफ आता है आपको क्या दिखती है? उसके टिप. You say dot. The vector अंदर की तरफ जाता है, you see a cross behind it, and therefore this cross. Look at this anti-clockwise circular motion. In this anti-clockwise circular motion, look at this curve. Curve is anti-clockwise. Look at the thumb. thumb is pointing out. If thumb is pointing out, we say that omega, its direction is what? Out. Out को define करने का तरीका क्या होता है? Dot. Again, this cross, you know, can also be defined as minus of k cap. अंदर जाने वाले वेक्टर्स को हम लोग क्या बोलते हैं? माइनस k cap. बाहर आने वाले वेक्टर्स को हम लोग क्या बोलते हैं? k cap. Therefore, now this omega has got a directional sense and a magnitude part. पूरी चीज क्या बन गई आपके लिए, उसको यहां देखना. Suppose we have a circle of radius 1 meter. If this radius is 1 meter and an object is moving in this direction with 10 meters per second, अगर आपसे बोला गया होता that throughout speed is what? Constant. Write down this circular motion, its velocity in vector form. तो आदमी क्या बोलता है यहां पर 10 j cap. Exactly here at 45 degrees. अगर आप फास्ट समझ पाए तो 10 by root 2 minus I cap plus 10 by root 2 j cap. यहां पर minus 10 I cap and so on. अलग अलग जगह पर आपको वेलोसिटी को डिफाइन करने के लिए I और J के अलग अलग कॉम्बिनेशंस को क्या करना होता? यूज करना पड़ता. लेकिन अगर मैंने आपसे बोला होता डिफाइन दिस होल थिंग इन टर्म्स ऑफ एंगुलर वेलोसिटी, तो आप क्या करते हैं? फर्स्ट ऑफ ऑल, व्हाट इज ओमेगा? ओमेगा इज व्हाट? v upon r. Omega is what? v upon r. R is 1 and therefore your omega is what? 10. ओमेगा 10 है. अब किसी ने आपसे बोला व्हाट इज ओमेगा, तो आपने तुरंत बोला 10 k cap. Thumb is out. What is out? K cap. Now, if you tell somebody this information that angular velocity is 10 k cap, तो वो आदमी इसको किस तरह से डिकोड करेगा कि भाई मैग्नीट्यूड तो कितना है? 10. And what is the direction? K cap. Which means you have to keep your right hand thumb out. Keep your right hand thumb out. Curl your fingers. What type of curl you see? Anti-clockwise. And therefore he immediately knows that angular velocity is 10 radians per second and its direction is what? K cap or anti-clockwise. Just because of this thumb. What is the direction of thumb? What is this line called? If you know, this line is called what? Axis of circular motion. Circular motion here, right? This is what? Axis of circular motion. We have a special thing, theta, omega, and therefore alpha. Small angle, कुछ भी हो, इन सब के डायरेक्शन कहां हुआ करते हैं? इन सब के डायरेक्शन कहां हुआ करते हैं? Along the axis, and therefore these all are called axial vectors. डायरेक्शन डिफाइन करने के लिए which hand one must use? Right hand. यहां पर what is the direction of angular displacement? If theta is small, we'll say what? Along the axis. You say along the axis or you say k cap along the axis out, anti-clockwise k cap. तीनों चीजों का मतलब क्या है? सेम. तीनों चीजों का मतलब क्या है? सेम. तीनों चीजों का मतलब क्या है? सेम. होपफुली समझ में आ गया होगा किस तरह से वेक्टर्स का डायरेक्शन आप डिफाइन करते हैं. ओमेगा का डायरेक्शन निकाल दिया, एंड सेम वे वी कैन डिफाइन डायरेक्शन ऑफ व्हाट? अल्फा. नाउ ये जो टेंजेंशियल एक्सेलरेशन वाला पार्ट था, अब जरा इस लाइन पर पहुंचते हैं. शायद यहां तक पहुंचने के बाद, इतना सुनने के बाद, अब आप जो अगला पार्ट है, तो मैंने आपसे बोला था that this tangential, this A is tangential acceleration, not the centripetal or not the total acceleration. तो वो आपको शायद अब यहां पर चीज क्लियर हो जाए. Look at this. अगर आपके पास एक ऑब्जेक्ट है और वो एक कांस्टेंट स्पीड से इस सर्कल में मूव कर रहा है, कांस्टेंट स्पीड. अगर स्पीड कांस्टेंट है, इसका मतलब ओमेगा भी क्या होगा? कांस्टेंट. अगर स्पीड कांस्टेंट है तो ओमेगा क्या होगा? कांस्टेंट. देयर इज नो चेंज इन ओमेगा। देयर इज नो चेंज इन ओमेगा मींस आपने क्या बोला, लुक एट दिस एग्जांपल कि आपने बोला यहां पर हर जगह ओमेगा क्या है, tan k कैप। फिर से सुनना, 10 मीटर पर सेकेंड, हर जगह पर स्पीड कांस्टेंट है एंड मोशन इज व्हाट, एंटी क्लॉकवाइज। आपने बोला एट एवरी पॉइंट ऑफ दिस सर्कुलर पाथ ओमेगा इज व्हाट, tan k cap. Is there any change in omega? You said no. If there is no change in omega, then for this type of circular motion your alpha is what, zero. What is alpha? Angular acceleration. अल्फा क्या है, जीरो। क्यों? क्योंकि जो हमारा ओमेगा आ रहा है वो ओमेगा थ्रू आउट क्या बना हुआ है, सेम कांस्टेंट। अल्फा अगर जीरो है then when you differentiated this thing you got what, dv upon dt as what, a। if alpha is zero then a must be zero, which means for this situation a is zero. Now in circular motion there are two types of A's. One is what, tangential, other one is what, centripetal. If you remember, कुछ हो जाए सर्कुलर मोशन में सेंट्रीपिटल एक्सेलरेशन जीरो नहीं हो सकता। क्यों नहीं हो सकता? क्योंकि सर्कुलर मोशन में कुछ हो जाए डायरेक्शन लगातार क्या होगी, चेंज। इसका मतलब ए अगर जीरो है तो फिर ये ए सेंट्रीपिटल नहीं हो सकता। What type of A is it? Therefore, tangential acceleration. होपफुली समझ में आ गया होगा क्यों इसको हम टेंजेंशियल बोलते हैं, सेंट्रीपिटल नहीं बोलते हैं। A इक्वल्स टू आर अल्फा, इसमें जो हमारा A है क्या है, वो टेंजेंशियल एक्सेलरेशन। नोट डाउन एवरीथिंग।